ma'am.
Yeah. So can you see the screen?
Yes, ma'am.
Yeah. So in the last class, what are the binary codes we saw? What are the codes? Can anyone answer this question? So what are the
Weighted code, XS3 code.
so actually
Great.
the codes we saw was BCD code, XS3 code, and gray codes. Actually, these are the codes.
Self.
So weighted codes and self-complementing codes are the group under which these codes come. So weighted codes example means BCD code and 2421 codes, and self-complementing code example is XS3 code. So actually codes only are BCD 2421, XS3 code and gray code. So these are the four binary codes we are going to study. So in that 2421, actually they're similar to 8421. So you will be writing the decimal number according to weight value 2421. So only 8421 and 2421 are grouped under the codes weighted code, and XS3 and 2421 are grouped under the codes self complementing codes. Is it clear? Is it clear or
Yes,
not?
ma'am. Yes,
So
ma'am.
next in the last we saw about the gray code. So actually the advantage of gray code is, so from going from one decimal number to another decimal number, in gray code representation only one bit will change, whereas in binary code representation if you go from one digital number to another digital number there can be any number of bit change. So in some it may have one bit change, or in some number it may have 2 bit or 3 bit, or all the bits can also be changed. So this may cause error while transmitting the binary numbers. So only in most of the case they will be using the uh, gray code. So gray code or advantage means, so that is it will if you are going from one digital decimal number to another decimal number, there will be only a one bit change. So how to write a gray code means, for the corresponding decimal number, write the binary value, binary number, and from binary number you can convert it to gray code. So for example, so you take the decimal number 6. So for how will you write the gray code means, so first write the binary number for gray code. Sorry, binary number for digit 6. So what is the binary number for 6 using 4 bits? You tell me using 4 bits. What is the
Zero
binary?
one one zero.
0110. So from the binary number, now you can obtain the gray code. So how you can obtain the gray code means, so first digit write as it is 0. So and the second digit you can write using first and second digit, you have to XR. You have to perform XR operation. So have you heard about XR operation? Have you heard
Yes.
about XR operation? Yes or no?
Yes, ma'am.
Yes. So what is the output for 00? 00, if you give 00 in the XR gate, what is the
Zero.
output value?
Zero, ma'am.
1, ma'am.
1. So for 01, output will be 0,
0, ma'am.
and 1
0, ma'am.
0, your output will be 0, and for 1 1,
One, ma'am.
is it correct?
0, ma'am.
Is it correct?
Ma'am, 000.
00 will be 0. You are telling
Zero one
the
one
gate
one
for
zero one one one
uh,
zero, ma'am.
00 will be 0, and 01 will be
One
1, and 10
one
will be
zero one
1, and 11
one
will
one
be
zero.
0. So this is the XOR gate. So XOR gate will be, output will be 1 if there is any input will be 1. So if both the input are 0 or if both the input are 1, your output will be 0. So, so in order to convert binary number to gray code, so first write the first digit as it is and perform the XOR operation for first bit, that is most significant bit 0 and second bit 1. So what is 0 and 1?
1.
0 and 1 will be 1. Then you perform XOR operation for these two bit 1 and 1. So what is the output for 1 and 1?
0.
0. Then you perform XOR operation for these two bit 1 and 0. So what is the value? 1 and 0
1.
will be 1. So this is the gray code of digit 6. So for in order to write the gray code for any decimal number, you write the binary number for that decimal number and from that you can convert it to gray code. So write the first digit as it is, that is most significant bit as it is, and the first and the second bit, that is most significant bit, and the next bit you have to take XOR and write the second bit. Then next two bits perform XOR operation and write the answer. And the next two bits similarly you can perform for any number of bits. This is the binary to gray code conversion. So take similarly you take another value. So for example you take 8. So you binary value will be 100. So in order to convert gray code, so write the bit most significant bit as it is, and then next bit is, so most significant bit and the next bit perform XOR operation. 1 and 0 will be 1 and 0 and 0 will be 0 and 0 and 0 will be 0. So for 8 decimal number your gray code will be 1100. Is it clear? So this is the binary to gray code conversion. So you can also convert gray to binary code. So you can also convert gray to binary. So gray to binary. So for example, take the same digit, that is 1100. So 1100 is a gray code. You have to convert it to binary. So what you have to do means write the most significant bit as it is. So write the most significant bit as it is. Now you perform the this XOR for this and the second bit. So first bit of gray code and the second bit of binary you have to perform the XOR. So 1 and 1 XOR will be 0. So then you perform these two XOR. 0 and 0 will be, sorry, 0 and 0 will be 0. Then you perform XOR for these two. So 0 and 0 will be 0. So this is the gray code and this is the binary number. So in order to convert gray to binary, so write the gray code. So most significant bit write as it is, and you have to perform XOR for first bit of your, that is most significant bit of your gray code, and the next second bit of your binary number. Similarly, you have to perform for the next corresponding bits, you will get the binary number. So in the university exam, they may give any number of bits. So for example, they will give any number of bits. They may ask you to convert either gray to binary or binary to gray. So binary to gray means, so you have to write the most significant bit as it is, and next bit of your binary number you have to perform XOR and write the gray code. And from gray to binary number, so you have to write the most significant bit as it is, and the first bit of your gray code and the next bit of your binary number, so that you have to perform XOR and you have to write the code. So this is what you can convert binary to gray and gray to binary conversion. Is it clear? Is it clear or not?
Yes,
Yes.
ma'am.
So, so that's all about the number system. So in the number system, we studied about decimal number system, octal, hexadecimal, and binary number system, and conversion among the other number systems. And we studied about binary addition, binary subtraction, and subtraction using complements. And then we studied about the binary codes. Binary codes, in that we studied about BCD code. So BCD code is very, very important, and BCD code is also known as 8421 code. So using that 8421 only, you are going to write the corresponding digits for uh, decimal number. So actually BCD code is not a binary number, it is a decimal number which is coded using ones and zeros. So you can directly code the decimal number using ones and zeros. So BCD code and binary codes are similar till 0 to 9, and after 9 BCD is coded using decimal number as it is. So if it is 1 0 means you have to code for 1 separately and 0 separately. If it is a 1 5 means you have to code for 1 separately and 5 separately. That is the BCD code. So and 2421 code is similar to 8421 code. So using the 2421, we are going to represent the decimal number. But the disadvantage is, so for same representation, you have one or more for same two, you can have one or more representation, because 2421ல இந்த 2 na யூஸ் பண்ணிக்கலாம் இல்ல அந்த 2 na யூஸ் பண்ணிக்கலாம். So you have some disadvantage. So you are not mostly using that 2421 code. So next code is XS3 code. So XS3 code is what for the corresponding decimal number. So that binary number plus 3 will give you the XS3 code. So any decimal number you have to convert the binary number, and binary number plus 3 will give you the XS3 code. Then next is the last is the gray code. So gray code advantages, that is from going from one decimal number to another decimal number, only one bit will be changing. So it is used in other any other applications while transmitting, because it will eliminate the error. So you can convert binary to gray and gray to binary using XOR operation. So this is all. So XS3 code and 2421 are example for self complementing code, and 8421 and 2421 are example for weighted codes. Is it clear about the number system? Is it clear or not?
Yes, ma'am.
Clear, ma'am.
Yeah, next we are moving forward to the Boolean algebra. So you would have heard the name about algebra. So algebra means, that is in maths you will be studied something like that, x plus y plus z, x plus y z plus uh, x y, something like that. So you would have studied about algebra. So here in algebra you will be having some variables, and you will be using the operations like addition, subtraction, multiplication and all. So here also you will be dealing with the Boolean algebra. The word Boolean means it has only two states. It takes only two states. That is, it takes either 0 or it takes only 1. So it takes only two states. 0 means false and 1 means true. Or you can, in other words, you can say 0 means off and 1 means on. So Boolean algebra. So the word Boolean means it takes only two states, that is 0 and 1 as input, and it also produces and gives an output only two states, that is 0 and 1. And also it uses the operations like logical operations. So even though you have x plus yz, so something like that means, so this plus indicates logical or operation, and this y into z indicates logical and operation. So Boolean algebra deals only with two states. So it takes only two input, 1 or 0, and it gives a any one of the two outputs, that is 1 or 0. So it deals only with two states. and it uses only logical operations. So either it uses a logical or operation or logical and operation, and also it uses a logical not operation. So not operation can be represented as y dash, or in some book they will be using it as a y bar. So either way you can represent as a not operation. So y dash or y bar. So you can either way you can use the not operation. So logical or logical and or logical not operation you will be using in the Boolean algebra. So Boolean states for only two states. So before proceeding to the Boolean algebra, so now we are going to study about the basic gates, basic logic gates. So you would have studied about basic logic gates. So we will go through it. So first gate is actually logic gate is a electronic device which accepts two or more input and produces an output using depending upon the logical function. So first gate is the OR gate. So OR gate can be represented as, that is, X is the input, Y is the input. This is the symbol of OR gate, and F is the output, where F is equal to X plus Y. So your plus indicates logical OR operation. So your truth table of this will be X is your input, Y is your input, another input, and F is your output. So for 0, 0, 0 plus 0 will give you 0. That is false, false. You will get the false value. Then next will be 0 and 1. For 0 and 1 input, you will get the output as, that is 0 or logical or 1 will give you false, and true will give you true. Then 1 and 0 will give you 1, and 1 and 1 will give you 1. So here you should not perform addition. That is 1 plus 1 is not 2. It is a logical OR operation. So 1 plus 1 will give you 1. That is true, and true will give you true operation. So this is the truth table of your OR gate. So is it clear? So for OR gate, this is the logical diagram. So this is the logical diagram. The F is equal to X plus Y is the logical function, and this is the truth table of the OR gate. So if they ask you to draw the logical diagram, means you have to draw this diagram. So logical expression, that is a Boolean function, is F is equal to X plus Y, and this is the truth table of the OR gate. So next gate is the AND gate. So AND gate, logical diagram of your AND gate is this one. So X, Y, and output is F, where F is equal to X into Y. So X into Y, that is you are performing logical AND operation. So X into Y is the Boolean function of the AND gate, and truth table will be X, Y, and output F. So 0, 0. So 0 into 0 will give you 0. And 0, 1. 0 into 1 will give you 0. And 1, 0. 1 into 0 will give you 0. And 1 and 1. 1 into 1 will give you 1. So this is the truth table of the AND operation. So F is equal to X into Y is the AND gate, and this is the truth table of the AND operation. Is it clear? Are you hearing me?
Yes. Yes,
Yeah.
ma'am.
So next is the NOT operation. So NOT operation, NOT gate. So you will have, for NOT gate, you will have only one input. So this is the NOT gate. So X is the input means for F. So F is equal to X bar. So this is known as the Boolean function, and your truth table will be X F. F is equal to X bar. So for 0, it will be 1, and for 1, it will be 0. So this is the NOT gate. So NOT gate will have only one input. AND gate and OR gate can have two or more inputs. You can also give any number of input to the AND gate and OR gate. So you will get only one output. And the next is the NOR gate. So NOR gate is the inverse of OR gate. So your So OR symbol plus your bubble in the end will give you the NOR gate. So X, Y and F. So where F is equal to Boolean function is F is equal to X plus Y the whole bar. That is, you have to perform X plus Y and then you have to complement it. So this is the OR gate. OR gate with bubble will give you the NOR gate. So your X and Y are input and F is the output. 0, 0, 0 plus 0 will be 0, and invert it, you will get 1. And 0, 1. So 0 plus 1 will give you 1, and invert it, you get 0. 1, 0. 1 plus 0 will give you 1, and invert it, you get 0. And 1 plus 1 will give you 1, and invert it, you will get 0. So this is the truth table of the NOR gate. So NOR gate is X plus Y the whole bar. So you have to perform OR operation and then invert it. So next is the NAND gate. So NAND gate is the inverse of AND gate. So this is the AND gate, and bubble at the end of the gate will give you the NAND gate. So X, Y and F is equal to X into Y the whole bar. So you have to perform X into Y and then you have to invert it. So truth table will be X, Y, then F. So 0, 0. So 0 into 0 is 0. You invert it, you get 1. And 0 and 1. 0 into 1 is 0. You invert it, you get 1. Then 1, 0. 1 into 0 is 0. You invert it, you get 1. And 1 into 1 is 1. You invert it, you get the value of 0. So this is the truth table of NAND gate. So X into Y the whole bar will give you the NAND gate. So symbol is you have to draw the AND gate and then you have to put a bubble at the end. This will give you the NAND gate. So next gate is the XOR gate. XOR gate is, so this is X, this is Y, and output is F, where output is equal to X bar Y plus Y bar X. That is, only one value should be 1 here. So 0 and 1. 1 should be 0, one variable should be 0 and another variable should be 1. And one variable should be 0 and another variable should be 1. Then only you will get the output of 1. Rest, if both the variables are 0 means, or if both the variables are 1 means, both the variables are same means, you get the 0 value. So that only your expression is X bar Y, that is X is 0 and Y is 1. and similarly y bar x, that is y is 0 and x is 1, then only you get the output f. So your XR can also be represented using x. This is the symbol for XR and y. So truth table, x, y and f. So actually you represent f. What is f in the truth table? So that will be fine. So 0, 0. So if it is both the input are same means you get the value of 0, and 0, 1 means 1. So 1, 0 means 1 and 1, 1 means 0. So if both the variables values are same means you get the 0 value, and our rest thing will be 1 value. So this is the XR gate. So XR gate can be written like can be drawn like this. So and f is equal to x bar y plus y bar x. That is x should be 0 and y should be 1, or else y should be 0 and y should be 1 and x should be 0. So next is the XNOR. XNOR is the reverse of XR gate. So that is how will you draw means you would have to draw XR and then you have to invert it. So this is the XNOR. So your f is equal to, so that is if both the variables have a same value you will get 1. That is either xy or it is x bar y bar. So this is known as the XNOR operation. That is your both the input should be either 1 or your both the input should be either 0. Then only you will get the output. So what is the truth table? So truth table will be x, y and then f is equal to, you can write the XNOR as symbol as this. So put a dot and circle it. This is known as XNOR. So 0 and 0. So if both the output are 0 means your output will be 1. 0 and 1 you will get 0, and 1 and 0 you will get 0, 1 and 1. So both the input are 1 means you will get the 1. Is it clear? This is the XNOR operation. So here both NAND gate and NOR gate are known as the universal gates. So NAND gate and NOR gates are known as universal gate because any function, any logic gates can be implemented using NAND and NOR. So that is AND or not XR, XNOR, anything can be represented. Any Boolean function can be represented using NAND and NOR. So that only it is known as universal gates. So implement in the in this unit, last topic will be implementation of NAND and NOR. That is, any Boolean function can be implemented using NAND and NOR. So any operation, that is OR, AND, NOT, anything can be implemented using NAND and NOR. That's why NAND and NOR can be known as an universal gates. Is it clear about logical gates, basic gates? Is it clear or not? So next you're going to study about the Boolean laws or theorems. Boolean laws or theorems. So actually you have certain set of rules in the Boolean algebra to reduce the Boolean functions. So your Boolean function can have any number of variables and it can include any logical operation. So using some set of rules or laws or theorems, anything you can say, using that you can reduce the Boolean function. So we are going to see what are all the laws you are going to use in order to reduce the Boolean functions. So first law is that is x plus 0. So here plus or into represents only the logical OR and logical AND operation, not a plus. So x plus 0 is equal to x, and x into 1 is equal to x. This is the first theorem. So x plus 0 is equal to x and x into 1 is equal to x. So if you have x plus 0 means you can write it as an x. So how will you remember this means? So you put x is equal to 0 here. So if you put x is equal to 0, 0 plus 0 will give you 0. If you put x is equal to 1, 1 plus 0 will give you the 1. So whatever value of x, you get the that value. So that only you can reduce x plus 0 is equal to x. Similarly, for x into 1, if you put x is equal to 0, so 0 into 1 will give you 0 and 1 into 1 will give you the 1. So whatever value of x, the output will be your same x. So first law is x plus 0 is equal to x and x into 0 is equal, sorry, x into 1 is equal to x. So this is the first law. Then the second law will be x plus x dash is equal to 1 and x into x dash is equal to 0. So if in any expression, if you have x plus x dash means you can directly put it as 1. And if you have x into x dash means you can directly put it as 0. So how is it means? You put x is equal to 0. So if x is equal to, if x is equal to 0 means 0 plus x dash is complement of x, 1. So what is 0 plus 1? You get 1. And if x is equal to 1 means then complement is 0. So 1 plus 0 is equal to 1. So whatever value of x you give, the value is 1. So x plus x dash is equal to 1. Suppose if you have forgot the law, உனக்கு எந்த law மறந்தாலும் சரி, இப்போ x plus x dash இருக்கு அப்படின்னா அது என்னன்னு மறந்துருச்சு அப்படின்னா you put the values for, you substitute the value for 0 and 1 and see what you get. Then you can easily remember the law. If you substitute 0 also you get 1 and if you substitute 1 also you get 1. So what is x plus x dash is equal to 1. Similarly, you come here. So if you put x is equal to 0 and x bar is 1. So 0 into 1 will give you 0 and 1, if you put x is equal to 1, complement is 0. 1 into 0 is equal to 0. So whatever value you put for x, your output is 0. So x into x dash is equal to 0. So this is the second theorem. Is it clear for you? Is it clear or not?
Yes, ma'am.
Yes, ma'am.
Yeah. So next law is x plus x is equal to x and x into x is equal to x. So this is the third law, that is x plus x is equal to, if you have x plus x means in your expression you can write it as directly x and x into x can be written as x. So you put x is equal to 0 and see. X is equal to 0 na 0 plus 0 equal to 0 and if you put 1, 1 plus 1 is equal to 1. That is OR operation. So whatever value x means you get the same value. So if you give 0 you get 0, if you give 1 you get 1. So x plus x will give you x. Similarly 0 into 0 will be 0 and 1 into 1 will be 1. So whatever value you give in x you get the output. So x into x is equal to x. So next law is x plus 1 is equal to 1. So many times they will confuse with, that is x plus 1 is equal to x. So you remember x plus 1 is equal to 1 and x into 0 equal to 0. So now you put x is equal to 0. If you put x is equal to 0, 0 plus 1 will give you 1 and you put x is equal to 1, 1 plus 1 will give you 1. So whatever value you give for x, you get the output as 1. So x plus 1 will give you 1 And similarly, if you put x is equal to 0, so 0 into 0 will give you 0 and 1 into 0 will give you 0. So x takes any value 0 or 1, but the output will be 0. So x plus 1 is equal to 1 and x into 0 is equal to 0. And the next theorem is law of involution. So next theorem is law of involution, that is x bar, the whole bar will give you the x. So that is x complement, and you take again that complement will give you the x value. So this is known as law of involution. And the next one will be law of commutative. So you would have studied in the maths commutative law. So what is commutative law? X plus y is equal to y plus x, and x into y is equal to y into x. So you would have studied commutative law in the maths itself. Then next law is associative law. So associative law also you would have studied x plus y plus z is equal to x plus y plus z. Similarly, x into y into z will be equal to x into y into z. So this is the associative law. And the next law is the distributive law. So distributive law is x into y plus z is equal to x into y plus x into z. And similarly, x plus y into z is equal to x plus y into x plus z. So this you will be often using it in the expression. So x plus yz can be written as x plus y into x plus z. So this is known as the distributive law. And the next law is law of absorption. ABSORPTION. So your next law is law of absorption. So that is x plus xy is equal to x. So that is if you have an x in both the term, that is x plus xy, means you can write this as x. So how you can prove this means you take LHS, that is x plus xy. How you can write using distributive law? Not distributive law. So you can take x common outside. So x plus xy can be written as x வெளியில எடுத்தீங்கன்னா x 1 plus y. So what is 1 plus y? You
1,
have
ma'am.
studied now. 1 plus
1,
y
ma'am.
is
1, ma'am.
1. So
1,
you
ma'am.
get the value as x. So your x plus xy can be directly written as x. So this law is known as absorption law. So absorption law, distributive law, associative law, commutative law, and involution law. So next theorem is De Morgan's theorem. So this is very, very important. So De Morgan's theorem is, that is, if you have x plus y, the whole bar is equal to, so x plus y the whole bar can be written as, you have to complement the individual variable, that is x can be written as x bar and plus can be written as into and y can be written as y bar. So this is known as the De Morgan's theorem. So I am writing in other words. So x plus y the whole bar. So in some book they will be using dash or they will be using bar. So x plus y bar can be written as individually take the complement of each variable. So x bar into y bar. So this is the De Morgan's theorem. So other theorem is in terms of into, and that is x into y the whole bar is equal to, you take individual complement value. X can be written as x bar. Instead of into, you have to write plus, and instead of y, you have to write y bar. So this is known as the De Morgan's theorem. So De Morgan's theorem states that for individual variable you have to take complement, and instead of plus you have to put into, and instead of into you have to put plus. Is it clear? So this law is very very important. You will be using in many expressions. So this is known as De Morgan's theorem. And the last theorem is consensus theorem. So state and prove, they may ask state and prove consensus theorem. So that is xy plus yz plus z x dash will be equal to xy plus z x dash. So xy plus yz plus zx dash means you can remove the center term. So this y will be in the first term and z will be in second term. But here x and x dash means you can remove this term. So this term is known as consensus. You can remove that. So this theorem is known as consensus theorem. So xy plus yz plus zx x dash. So here x and here x dash, and the center yz is y இங்கேயும் z இங்கேயும் இருந்ததுன்னா இந்த yz நீ remove பண்ணிடலாம். You get only xy plus zx dash. So how will you prove this? So you take LHS alone, xy plus yz. So yz ஓட கூட you multiply x plus x dash plus third term is zx dash. You know x plus x dash is 1. So if you multiply yz into 1 also, you don't get any changes. So multiply yz with x and x dash, that is this x and this x dash value. So now uh, expand this, you get xy plus xyz plus x bar yz plus x bar z. So xy is common here. So xy வெளியில எடுங்க, 1 plus z plus x bar z is common here. You take 1 plus y. So 1 plus z will be 1 and 1 plus y will be 1. So you get xy plus x bar z. Is it clear? So you get the RHS value. So this is the proof for the consensus theorem. So consensus theorem states that xy plus yz plus zx dash is equal to, if you have this yz in this term and z in this term, and you have x and x bar, means you can leave the second term, that is xy plus zx dash. So they may ask you to prove in 2 marks, state and prove the consensus theorem. So in terms of addition, the same theorem can be written as x plus y into y plus z into z plus x dash will be equal to x plus y into z plus x dash. So y here and z here, you have x and x dash means, so this term can be eliminated. So this is known as consensus theorem. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
So these are the laws and theorems you are going to use in the reduction of Boolean expressions. Is it clear till now?
Yes, ma'am.
So rest of the thing we will continue in the next class. So if you have any doubt regarding this, you can Ask now. If you have any doubt, you can ask.